students, this is Vimal Kumar, Vice Principal, Narayan English Medium School, Jaipur, Odisha. So, in our last video, we had gone through class 10 science, chemical reaction and equations, in which we had gone through various basic definitions of chemical reactions and equations. Today, we will go through types of chemical reaction, in which we will go through basically types of chemical reaction, that means combination reaction, decomposition reaction, displacement reactions, and especially reactivity and corrosion. So let's start with our first chemical reaction, that is combination reaction. Now, what do we mean by combination reaction? As the name suggests, combination means combined. In this reaction, two or more reactants or substances will combine to form one or more product or products, right? So I am repeating the thing. Combination reaction is a reaction in which two or more substances are being combined to form two or more products, or even one product, two product, three product, anything. So combination means combine. Let's take an example. Here we have gone through carbon, oxygen. So carbon is a special gas, oxygen is a special gas. So we got here two reactants, and combinedly what they got? Carbon dioxide. So they combined, they joined to get one product. One more example, similarly hydrogen and oxygen, they combined to form the molecule of water. Similarly methane, oxygen, they combinedly got carbon dioxide and water molecule. So all these are combination reaction. So in case of combination reaction, what happens? Two or more substances combine together to get few substances. It may be one, it may be two, it may be three. One thing here taken into consideration, I have written here, when CH4 had reaction with oxygen, we got carbon dioxide, we got water molecule, and one more thing, that is heat evolved in that reaction. Heat came out in the reaction. That is not evolving of heat. So heat evolved. This type of reaction is known as exothermic reaction. Means the reaction in which heat will be evolved, that is known as exothermic reaction. So in combination reaction, one reaction we had seen which is exothermic, heat evolved from the reactions. So combination reaction, in combination reaction basically two or more substances join to get two or more products. That's it. Next, let's move to decomposition reaction. What is decomposition? Simply again, decompose means divide. Here the substances will be divided into two or more substances. Means the reactant or reactants will divide into many more products. That is known as decomposition reaction. Here I am going to give you various examples for it. Let's go in depth. First one is, I have written here thermal. That means a reaction in which we require heat. Means for this reaction, means calcium carbonate. To decompose it, we require heat. Thus, this is known as thermal reaction. So when calcium carbonate get heat, we got calcium oxide, we get carbon dioxide. Similarly, let's take another one, electrolytic. What is that electrolytic? Electrolytic in which we require electric current for the reaction. So here H2O, that is water molecule, provided with electric current. When we pass electric current through water molecules, it is divided into two products, hydrogen and oxygen. So here, as electric current is required, so it is known as electrolytic. Next, photolytic. Here again, silver chloride. When silver chloride got sunlight is photolytic. When we got silver chloride, we put it into sunlight, it is divided again into silver and chlorine. Let me tell you, this particular photolytic, particularly silver chloride, in camera we used to instant photos, that is there it is required. Right? However, so decomposition reaction, what is decomposition reaction? In decomposition reaction, two or more substances are being divided into various substances. Means two or more reactants, okay, divided into various products. Here, the single things like calcium carbonate, water, silver chloride, they've been divided into here. Calcium carbonate divided into calcium oxide and carbon dioxide. Here, water into hydrogen and oxygen, where silver chloride into silver and chlorine. Right? These are decomposition reaction. Now again, here we had gone through exothermic reaction. Here, endothermic reaction. Here, gas is evolved out. Here, heat is required. Here, in this process, heat evolved from the reaction. Whereas here, heat required in the reaction. So, two more definitions. Endothermic and exothermic. Endothermic reactions are those reactions where we require heat for the reaction. And exothermic reactions are those reactions where heat evolved from the reaction. Yes. Right? So, we had gone through combination reaction and decomposition reaction along with two definitions, endothermic and exothermic. Let's take an example, two more in decomposition reaction. Ferrous sulfate got heat. FeSO4, when we heated that, we get FeO3, we get SO2, we get SO3. Three products from one substance. Here, one substance is divided into three products. Similarly, let nitrate, PbNO32, best two, where if we provide heat, then it goes to lead oxide, nitrogen oxide, and oxygen. So, in this way, decomposition reaction, we had gone through one or more substances is being divided or decomposed into various products. Right? So, this is combination and decomposition reaction. So, now our third one, that is displacement reaction. Now, what is displace? Displacement, taking a thing from its place to another place. Displace. So, as the name suggests, in case of displacement reaction, two or more substances react with each other, but the highly reactive one will take out the lower reactive one and new products will be created. New products will be coming into existence. How? Let's take an example. In this FeCO4, iron and copper sulfate, when they reacted each other, as the sulfate is being reacted higher basis with iron, because iron is higher reacted than copper. So, here copper sulfate changed into ferrous sulfate, iron, and the copper which was displaced out. So, Fe plus CuSO4, they reacted each other, but here as iron is more reacted than copper, so iron react with copper sulfate means and take copper out and copper now alone. This is known as displacement reaction. Now here, one thing, let's remember in our chemical reaction, in one thing we had gone through that, in a reaction, the colors may change. Let's take an example of this even then. Here, iron nail, which is brownish color, because deposition of copper. Similarly, the copper sulfate, which being converted into dirty green color because of copper come to Fe, right? So copper moved out and iron moved in. So in this way, this copper sulfate become dirty green color. So this is displacement reaction. So what is displacement reaction? In which one or more element or atom is being displaced from their chemical base and one or more things will come in place of that. So here iron plus copper sulfate. When we dip iron nail, we pour iron nail in copper sulfate, the reaction took place and copper sulfate became iron sulfate. right? So copper moved out, iron moved in. So iron displaced copper. This is displacement reaction. This is single displacement, only iron displaced copper. We may get even double displacement reaction. Now second thing is, means the fourth one types of chemical reaction is double displacement reaction. As the name suggests, what is double displacement? Here only one displacement was there, here two or more displacement will be there. Let's go to the example. NO2SO4 BaCl2. See here we have Na2 SO4 barium chlorine. Now when they react with each other, the sodium sulfate and barium chloride, when they react with each other, now these two will exchange. See, Na2SO4 became BaSO4. That means Na2 Ba means barium basically came over here. That means in case of Na2, Ba took the place. So barium is much more reactant with sulfate. Similarly, now Na2, that sodium is much more reactant with chlorine. So here it comes. So here in one way, the sodium and barium, they took their place, they changed their place. So in one way, Na2 came over here, in one way, Ba went here. So double displacement. So here we come across double displacement reaction in which the reactants change their places. Right? Not only that Na2 will come only here and then only Ba will come over here. There may be a case, there may be some extreme things where Na2 come over here, they join one thing, some other reactant might be there, which may come to there. So means here more there one displacement will be done. Thus this is known as double displacement reaction. I am coming again. In case of displacement reaction, only single one, where single atom will displace, means your displaced single atom. But here more than one atom will be displaced. Thus this is known as double displacement reaction. Down through single displacement and double displacement reaction. This is displacement reaction. So now our last types of chemical reaction. We had gone through combination, decomposition, displacement, double displacement. 4. Now the fifth one, oxidation and reduction. Oxidation means oxygen is added. Right? Now what is reduction? Oxygen is removed out. So here, however, one more thing even here required, that is hydrogen. So what is oxygen? Oxidation is nothing but in a reaction where oxygen is being added or hydrogen removed. Similarly, reduction where hydrogen added and oxygen removed. So two gases mainly, hydrogen and oxygen. Here the main part is oxygen. Oxidation, oxygen added. Reduction, oxidation removed. Here cases may be there where hydrogen removed and here hydrogen added. Right? So oxidation are those reactions where oxygen is being added and hydrogen removed. Similarly, reduction is reactions in which basically oxygen is removed and hydrogen is added. Let's go through some examples. For example here, carbon, which is being added with oxygen and we get carbon dioxide. Similarly, copper, when reacted with oxygen and provided heat, this is, remember, which reaction? Endothermic reaction. Heat is being required in this reaction. So, now let's come to the point. Copper, when reacted with oxygen by heat, here oxygen is added. So, in both the cases, we have seen oxygen is added. Thus, these are oxidation reactions. Similarly, let's come to the reduction. In reduction, manganese oxide, when reacted with hydrochloric acid, Then here MnCl2. Remember, this is displacement. MnCl2, manganese chloride. And this O2 came over here. Means oxygen moved out from here. So H2O. And one more product we get, chlorine. So this is a case of reduction where hydrogen is being added and oxygen is being removed. Manganese oxide, when reacted with hydrochloric acid, we get MnCl2 manganese chloride. Okay, this is again, we could see displacement one, right? And H2O, where oxygen is being removed out and chlorine is different. So this is a case of reduction. Now, let's go through one more example where we will find both the things at a time, right? Like when cuprous oxide reacted with hydrogen with heat, means here again this is an endothermic reaction. Cuprous oxide reacted with hydrogen. In this case, first let's see, Cu and O, oxygen will be removed here. So this is a reduction case. Similarly, hydrogen is here. Sorry, hydrogen, it is being added with oxygen, so oxidation. Same reaction where we got reduction and oxidation, right? So these are the types of chemical reaction, and this is the last one, oxidation and reduction. So now today our last topic of this chapter 1, effects of oxidation and prevention. Now, oxidation we came across just before. Now, what are the effects of oxidation and how to prevent them? Right? Oxidation, I have told you people already, that is, oxidation is a reaction in which oxygen is added. Oxygen is added to the things. Right? So here, some basic examples we came across in our daily life is corrosion. Now, what is corrosion? Basically, when metal, any metal exposed to air, moisture, acid, they started reacting with oxygen. Right? I am repeating. When any metal exposed to moisture, air or acid, they started reacting and the metal became corroded. This is known as corrosion. Right? So, metal corroded, right? Corrosion, metal exposed to moisture, air and acid, it becomes corroded. Now, example as I told you people, rusting of iron. In silver, basically black woods happens. When we use silver rings and something, after some time period we will see some black marks in that. That is nothing but oxidation. Similarly, green color in copper, if we will go for copper rings and copper things, then there will be green coating on that. Even whenever we use the rings, copper rings, then even in our hands we will find some green colors. That is only this reaction. Right? So, these are the basic effects which is known as corrosion. Now, how we will get out of this? Because we couldn't make our metals, we couldn't make our belongings just like that only. So, to prevent them, we have method galvanization, electroplating, and that is simply, in simple manner, what we could say that we have to color our metals. Like on iron we are giving paint, but on rings we couldn't give paint like that. For that we have electroplating or galvanization. These are the methods in which our precious metals are being colored, by which they will not be coming across this corrosion. Right? Next, the last topic is rancidity. Again, this is in our daily life we are coming across these things. Oxidation again. You might have seen some food materials, if you will keep in a home for a longer period, we will get a foul smell from that. What's that? Or oil smell from that. What's that? That is only rancidity, which is again reaction, that is an oxidation. So, oxidation of this weight, particularly the fatty things or oily things, when they come across this oxygen, they give a foul smell, they give a bad smell. Even the taste will be quite degraded. That's due to rancidity. Now how to solve that? How to prevent that? You know, for that reason generally we are keeping our food materials like particularly these fatty and oil things in closed container, that is airtight container. Generally we are going through airtight container. Similarly, in some cases the air will be, in some particular refrigeration case, okay, the air is being moving out by nitrogen. This is a special reaction in basically refrigeration case. These things are being done where we keep our food materials in refrigerators, right? The same thing is being done here. This is a case of rancidity. So our last topic was effects of oxidation and how to prevent those things, and in our daily life we are coming with these things, that is rancidity. So in these videos we had covered chemical reaction, chemical equation, how to balance chemical equation, what are the types of chemical reaction, and lastly the oxidation and prevention. In this chapter of class 10 science chapter 1, only this much. Thank you.